Hello chemists and welcome to Bale's Chemistry. In this episode I'm going to introduce buffers and explain how they work. This is AQA Specification 1.12 and it's on paper 1 of your final exams. If you haven't already, hit the subscribe button below to make sure you don't miss out on our weekly videos. A buffer is a chemical that is designed to resist changes in pH, and they are formed by establishing an equilibrium. Adding an acid or a base shifts the equilibrium but maintains the concentration of hydrogen ions in solution. A buffer will also resist the change in pH when it's diluted. There are two main types of buffers that we need to know about the AQA syllabus, ones that are formed from weak acids and ones that are formed from weak bases. Acidic buffers are made with an equilibrium between a weak acid and a salt. The most common example of a solution is ethanoic acid and a salt of ethanoate ions. Basic buffers are made from an equilibrium between a weak base and a salt. A fairly common example that we see in the syllabus is ammonia with ammonium ions. We'll first begin by taking a deeper look at acidic buffers. To form this buffer, we'll have a solution containing ethanoic acid and sodium ethanoate. Sodium ethanoate is our source of ethanoate ions, which are the salt for ethanoic acid. The ethanoic acid splits apart to form hydrogen ions and ethanoate ions. Because this is a partial dissociation, there's some original HA molecules present, and we can use the Ka value to determine the ratio. Sodium ethanoate splits apart in solution to form sodium ions and ethanoate ions. This is a complete dissociation. In our acidic buffer solution, there'll be 4 different species present. However, the sodium ions act as spectators and have no influence on the equilibrium. Once the equilibrium is established, there'll be a higher concentration of ethanoic acid, or HA, and a higher concentration of the ethanoate ion, or A-. The concentration of H+ will be the smallest in the equilibrium. It's important that we can describe what will happen if we add an acid or base to our buffer. The important thing to remember is that acidic buffers resist a change in pH by maintaining their hydrogen ion concentration. If we add hydrogen ions to the solution, they will react with the excess A- or the ethanoate ions in our example, and this will push the equilibrium to the left, creating more ethanoic acid, or HA, and decreasing the amount of ethanoate ions. The concentration of hydrogen ions will remain almost the same. The reactions are different if we add a small amount of strong base. The hydroxide ions react with the hydrogen ions to form water, and then the equilibrium shifts to the right to reform the hydrogen ions which has been removed. This dissociation causes the concentration of HA to decrease and the concentration of A- to increase, whilst leaving the concentration of H+ almost the same. In the AQA course, we don't focus that much on basic buffers, but you need to be able to explain how they work. Basic buffers have a similar way of working as acidic buffers, in that they establish an equilibrium between the weaker base and its salt. The most common example you're likely to come across is a buffer formed from ammonia and the salt ammonium chloride. Ammonia forms an equilibrium between ammonium molecules, hydroxide ions, and ammonium ions. These are formed by reaction with water molecules when the ammonia gains a proton from the water. Ammonium chloride completely dissociates to form more of the ammonium ions and the spectator chloride ion. Once we have all the species present for the buffer, we again establish an equilibrium. This contains more of the ammonia and the ammonium ions than the hydroxide ions. It's the concentration of these hydroxide ions which maintains the pH in the solution. Once the equilibrium is established for the buffer, it will resist changes to the concentration of hydroxide ions. When the hydrogen ions or acid molecules are added, they'll react directly with the hydroxide ions to form water. This loss of hydroxide ions and the increase in water molecules will shift the equilibrium to the right. This lowers the concentration of ammonia, increasing the concentrations of ammonium ions, and restoring the concentration of hydroxide ions. The opposite will happen if we add hydroxide ions to the buffer. The concentration of hydroxide ions will temporarily increase before the equilibrium shifts to the left to counteract the change. In doing this, the concentration of ammonia will increase and the concentration of ammonium ions will decrease, leaving the concentration of hydroxide ions to be returned to almost the same as they was before addition. So to quickly summarise, acidic buffers are made up of weak acids and their salt. When the acid is added, the equilibrium shifts to reduce the concentration of hydrogen ions, forming more HA, keeping the concentration of hydrogen ions almost constant. When a base is added to this buffer, hydrogen ions are initially removed before the equilibrium shifts to oppose the change and produce more hydrogen ions by dissociating more weak acid molecules. Basic buffers are made from the weak base and its salt. If an acid is added to the solution, then it will initially react with the hydroxide ions, forming water. The weak base will then produce more hydroxide ions by reacting with water, and this will restore the concentration of hydrogen ions, keeping it almost constant. If a base is added to the equilibrium, it will shift to remove the added hydroxide ions by reacting them with ammonium ions to form ammonia and water. That's it for this episode of Bales Chemistry. Lots of little details again to make sure you're confident with. Don't forget to like and subscribe, and thanks for watching.